In this video, we're gonna do the following problem. We have several elements of group G, and we would like to show that the inverse of the product from x1 up to xn is exactly the product of xn inverse up to x1 inverse. So first, we need to know what is the meaning of inverse of an element in the group. So let's say A is in the group G. The inverse element of A is another element. Well, it is not necessarily different from A, so it is an element B in G such that if we multiply A with B either to the left or to the right, we get a neutral element. So here E is the neutral element, which is the element where wherever we multiply any element of a group with this E, we get back that element. Okay, so if we multiply from the left or from the right, we get a neutral element. That's the definition of inverse. So now, the claim of the problem is that it says that the inverse of the product of x1 up to xn is on the right hand side. Okay, so according to the definition that we just mentioned above, it is enough to check that the right hand side of that star equation, if we multiply to x1, x2 up to xn, either from the left or to the right, we get back the neutral element. Okay, so we just need to multiply the right hand side with x1, the product of x1 up to xn, to the left and to the right. Okay. Well, what you will see later is an argument that can be formalized, that can be argued more formally using induction. But just for the idea, I think the following argument is good enough. Okay. So now let's take the right hand side of the star equation, which is xn inverse up to x1 inverse, and then multiply to x1 up to xn, the product of x1 up to xn. And since the product is associative, then we can multiply x1 inverse and x1 first, right? So this is actually the generalized associative property. If you don't have that yet, you may want to try to prove it. Okay, since x1 inverse times x1 is the neutral element, so we can just erase or doesn't write the neutral element. And if we keep doing that, okay, so for example, x2 inverse times x2 become the neutral element. Then at the end, we have xn inverse times xn, which is the neutral element. And similarly, now we just need to check what is the result of the product of x1 up to xn when we multiply with the proposed inverse, which is xn inverse up to x1 inverse. Okay. Similarly to the above, we can multiply the middle terms first, which is xn times xn inverse. And we know any element of group, if we multiply with its inverse, we get the neutral element. And anything times the neutral element, so xn minus 1 times the neutral element is xn minus 1. So we don't really need to write the neutral element explicitly. Or in other words, the xn inverse disappear, right? And if we keep doing that, xn minus 1, xn minus 1 inverse disappear, and the last one to disappear is x1 inverse, which is also the neutral element. So the claim is true that if we multiply to the left or to the right of x1 times x2 up to xn, the result is the neutral element. So we are done. And then we can conclude that the claim is indeed correct. Okay. And as I said earlier, if you are uncomfortable with the argument that like the middle term disappear and then keep doing that until the last one is x1 inverse, then you can argue this more formally using induction. Okay, so that's all for today. Thank you for watching. Bye bye.